So, hi Akansha. I guess we can wait for like 5 or 10 minutes so that a few other people can join the session. So we can start in like 6 7 minutes. Okay, so I guess no one else is joining the session, so maybe we can just get started. And if anyone comes along, then I'll just brief the person about what we have discussed. So just to reintroduce myself to everyone who's watching on YouTube. So hello everyone. I'm Lakshya Saggi, the Discrete Maths NPTEL TA for the Monday 6 to 8 p.m. sessions. So in this session, we'll be discussing about one of my favorite topics, which is like generating functions and sequences. And like why I find this topic very beautiful is the ideas used in this is are very elementary, but it's the applications of generating functions are like infinite. You can find a lot of applications of generating functions, and they don't use any fancy mathematics either. They are just very basic objects, uh, and the mathematics behind them even a high schooler can understand. So yeah, that's why I kind of really like generating functions. So I have again, as usual, a bunch of problems prepared. So maybe I can just share my screen so that we can start discussing the problems. Okay. So I hope my screen is visible to everyone. So Kansha, if my screen is not visible at any point of time, then like you can, or if there's a issue with my audio, then you can ping me in chat and I'll try to fix it. Otherwise, I'll just assume everything is going along smoothly. So yeah. So once again, maybe before starting the session, I like to just remind everyone about the basic definitions which we'll need. I'll be assuming that you guys have gone through the lectures, but still, let's just revise some basic definitions. So, first of all, what is a sequence? So, sequence is nothing but a series, but an index series of numbers. So, sequence is a series of numbers which are indexed. So, like first element, you can refer to it as a naught, second element as a1, third element as a2, and so on. So you have a natural indexing from the set of non-negative integers to the set of real numbers, and this is what you call a sequence. So some people also like to define sequence like this, like mapping from non-negative integers to real numbers. So a mapping is just means a function. So a mapping from non-negative integers to real numbers can also be like thought of as a sequence can also be thought of as something like this. Why? Because if you have a function and like its domain is non-negative integers, then f of what would be the value of f of 0 in this case? So f of 0 will say it is equal to a naught. Similarly, f of 1 will say is a1, f of 2 is a2, and similarly f of I is ai. And that's why one can define something like a mapping. And people like to refer to sequence as this also. But on a very high level, sequence is just an index series, a series which is indexed. So yeah. And then what is a generating function? So generating function for a sequence. So generating function is always defined with respect to some sequence. So let's say the sequence given to us was this a naught, a1, a2, a3, so on. So the generating function for the sequence would be a naught plus a1x plus a2x squared, so on, and like till infinity, like till wherever this sequence goes. So yeah, and that will be our generating function too. So one can write it as something like this also. Like it's just summation of ai x to the power I. Maybe I should write that also. But this is nothing but sum over I equals to 0 to infinity. Maybe Okay, I don't remember the symbol for infinity, so maybe I should just like this. Summation I greater than equal to 0. AI x to the power I. So the thing is, yeah, I hope it's fine. So it's sigma over all I summation AIX. Yeah. So summation over all I greater than equal to 0, AI x raised to the power I. This is what we call generating function of a sequence. So this is just a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 till infinity and something like this. So, and uh, if a generating function for a sequence is, let's say, fx, if we are given generating function for a sequence as fx, then the ith term, which will be ai, is just the coefficient of x to the power I in the expansion of fx. So just the reverse of this. Like you can see from this that coefficient of x to the power I is just ai in a generating function. And that is what we are referring to, that ith term. So ith term will, by ith term will mean ai. So ith term is coefficient of x to the power I in the expansion of fx. Yeah. So just note that this is a bit of a convention. One might get confused that like this is a convention one can adopt, but note that what would be if you put I equal to 1, then first term here would be A1. But note that sequence usually starts from A0. So don't make this sort of like, this is a very common silly mistake, guys. And uh, this is something people get confused about. So please don't get confused about this. So the term A0 will be the 0th term of our sequence, and A1 will be the first term, because usually it's a habit that the anything which comes at the start is the first term for us. So people like to refer to it as first term also. But strictly speaking, this is the 0th term of the sequence. This is the first term of the sequence. This is the second term of the sequence, and so on. So we'll keep this sort of, this is more of a notation, like which everyone has adopted. So we'll also be adopting this, that this will be 0th term, first term, second term, and so on. Yeah, I hope this is clear and what I mean by it. So then maybe we can start with the questions for today. So first question says that what is the closed form expression of the generating function for the sequence 707070? So here you can see that 7 and 0 are alternating, and this goes on till infinity. This dot 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 denotes that this goes on till infinity. And now we are asking whether, like, what's the closed form expression for the generating function of this sequence. So here, first of all, let's just see what's given to us. Uh, so we are given that the term at the start is always A0 for us. Note that this is not A1, this is A0. Like we'll always be starting from A0 in a sequence. Just remember this. Yeah. So we are given that A0 is 7, A1 is 0, then A2 is again 7, then A3 is again 0, and like it goes on. The 7, 0 alternating is go on. And let's say the generating function for this is fx. So let's just assume that the generating function is fx. Then what's the expansion for fx? Let's just write down the expansion for fx first, and we'll come to the closed form expression later. So note that there's a difference between the expansion and the closed form. So this is what you call the expansion, the summation aix to the power I. And if you can write this function compactly, then that is what you call a closed form expression of the function. So first, let's write down the expansion, and then maybe we can arrive at a closed form. So what will be the expansion here? So expansion will be just 7, because expansion is just summation aix to the power I. So first we put a naught is 7, then a1x, a1 is we are given as 0, so 0 times uh, x raised to the power 1. So maybe I'm just writing down it explicitly, and maybe we'll cancel this 0 later. And similarly, then again we have a 7, so it's 7x squared, then again a 0x cubed, and so on. This goes to, and like we can just write it as like, we can just leave these zeros aside, and we'll arrive at something like 7 plus, because 0 into anything is 0, so we don't need to consider those terms. So this is just 7 plus 7x squared plus 7x to the power 4 plus 7x to the power 6, and again this like just goes on till infinity. Now, Akansha, would you like to answer? Like, what will this be equal to? Like, suppose we have this infinite sum. So this is the expansion for us for fx. 7 plus 7x squared plus 7x to the power 4 plus 7x to the power 6, and so on. And we'll like to write a closed form expression for this. And what I claim is like you guys have seen these forms of expression in even your high school. So, okay, cool. So Kansha has answered in the chat that the answer is 7 upon 1 minus x squared. So yes, Akansha, your answer is correct. So good job. So it can just be seen that so to everyone who's watching on YouTube, so this is nothing but you can just take the 7 out here, and this will not be just x squared plus x to the power 4. This is from 1, sorry. 1 plus x squared plus x to the power 4 plus x to the power 6, and this goes on to infinity. And this is nothing but a sum of an infinite GP, where the first term is 1 and the common ratio is x squared. First term is 1, second x squared, third x to the power 4, x to the power 6. And this sum is, we have studied in high school also, this has been covered in lectures also. So this is nothing but 7 times. This value is just equal to 1 upon 1 minus x. 1 divided by 1 minus x squared, sorry. And this is, so this is the answer for us, and like this is nothing but 7 divided by, okay, I'm doing a lot of typos today. 7 divided by 1 minus x squared, and this is our answer. So note that in closed form, we want something like a very small expression. We don't want this whole expansion. This is the expanded form of the generating function, or what we call the expansion of the generating function. And this is a closed form. Note that they denote the same generating function, but this just denotes it more compactly. So yeah. Okay, then let's come to the third question. So, okay, so second question only. So the second question says that what is the coefficient of x to the power 4 in 1 minus x raised to the power minus 5? So we know from binomial theorem at least, suppose this was not 1 minus x raised to the power minus 5, but it was 1 minus x raised to the power 5 instead. Then I believe this problem would have been much easier, because you guys must have seen it in like high school also, and we have also, I believe, previously discussed the binomial theorem. So if it was just 1 minus x raised to the power plus 5, and we had to find coefficient of x to the power 4, then it would just be something like 5 choose 4 or something. Yeah, it would be 5 choose 4. But now the coefficient is now, but now the exponent is negative. And in this case, this has been discussed in the lectures that uh, in these kinds of expansions, maybe I'll just write down the formula so that it's sort of a revision for you guys. So the coefficient of x to the power r in the expansion of 1 minus x raised to the power minus n is given by something like n plus r minus 1 choose r. N plus r minus 1 choose r. So you can actually prove this formula also, but I believe it's much easier to just remember it because you can, if many questions come related to this formula, then you can just straight away do it if you remember this. Coefficient of x to the power r in the expansion of 1 minus x raised to the power minus n is given by this formula, n plus r minus 1 choose r. I hope it's clear. It's visible. Yeah. So if we know this in general, and here what we want to find is, and note that here n is greater than or equal to 0. Like this formula won't apply if n is negative, because if n is negative, then this would just become 1 minus x raised to the power something positive. And then you can just find the answer using binomial theorem. So you don't need this formula anyways. But if n was negative, then you will need this formula. And this just says something like this. And here we know we want to find out coefficient of x to the power 4. So what is r equals to here? We just put r equals 4. And in 1 minus x raised to the power minus 5, we just put n equals to 5. Because if you put n equal to 5, this will be 1 minus x raised to the power minus of 5, which is this thing. So yeah. Just put it like this. Putting n equals to 5 and r equals to 4, we get, so n equals to 5 and r equals to 4, so it would become something like a 5 plus 4 minus 1, choose r, so r is equals to 4 here, so choose 4, and this will come out to be something like 8c4, and 8c4 is, yeah, let's write this down. So 8c4, and 8c4 will be equal to 8 times 7 times 6 times 5 divided by 4 factorial, which would be 24. So 8 times 6, 5, 2, 35. So this will come out to be 70, I believe. So if you think that this is, my calculation is incorrect, then feel free to call me out, but I believe this is correct. The answer would be 70. Okay, so we obtain that the coefficient of x to the power 4 is 70 here. So now coming to the third question. So again, third question is a pretty simple question, but still, like I would like to cover this because it's also a cause of silly mistake among students. So what do people do? So here we are asked, like, what is the sequence in the generating series for the expression this? So we are given a generating function and we have to write the sequence corresponding to this generating function. And we already know, like, how to convert a sequence to a generating function and a generating function to a sequence. So here we can see that coefficient of x to the power 1 is 0, x to the power 2 is 0, x to the power 3 is 10, x to the power 4 is again 0, x to the power 5 is 12, x to the power 6 again is 0 because we have x to the power 7, and we have x to the power 8 as 0 because x to the power 8 is not present, but we again have x to the power 9 as 1. So it starts with zeros and then it alternates between like 10, 0, 12. Okay, I think after 12 also, we might have a 0, yeah. After 5, we don't have x to the power 6, so we have a 0 here. Then x to the power 7, a 14, then 16, So the sequence first starts off with two zeros, and then it alternates between like an AP of 10, 12, 14, 16, and a sequence of zeros, something like this. And this goes on. So do you think, Akansha, that is this the correct answer? Akansha, any comments? If what I've written is correct? Yes, exactly. I wanted to uh, let you catch it. Nice, good job, Akansha. So yeah, so the sequence should start with three zeros. So I just wanted to again focus on this point that please don't forget the coefficient of the constant term in the generating series. So in the generating function, we always have a constant term also, which is the value of n. So please don't forget it anytime. So here we see that the constant term is also zero. So that's why a naught is also zero. Then a1 also is zero and a2 is zero. So that's why we should start with three zeros, not just two zeros. And then we can alternate from 10, 0 to 12, 0 to 14, 0 to 16, 0 and so on. So just keep in mind, guys, that we don't have to forget the constant terms. Yeah. So this would be the answer for us. I can just underline it also. Yeah. And so good job, Apansha, in catching it out. So now we have the fourth question, which is like, should put some space between all the questions. So what is the closed form of the generating function of the sequence 0, 1, 2, 3, 4 until infinity? So we have this sequence and we want to find out the generating function and its closed form. So first of all, let's write down the generating function. So let's just see what the values of a naught a1 are. So we know that a naught is 0, a1 is 1, a2 is 2, and so on. So how do we write the generating function? Generating function f of x. So the generating function f of x is equal to nothing but a naught plus a1x plus a2x square and so on. So a naught is we are given as 0, then a1x will be 1 times x, then a2x square will be 2 times x squared, then 3 times x cubed, and so on. And this is nothing but like this 0 can be neglected because it's a 0. So and this 1x is nothing but equal to x. So this is actually equal to x plus 2x squared plus 3x cubed plus 4x to the power 4, so on. And now we want to find out the sum of the series. So we can just write it down there. So we want to find a closed form expression for this, right? So first let's write down something like this, that this is equal to x times 1 plus. So we just take out x common from all these. So it will be x times 1 plus 2x plus 3x cubed plus this will be 3x squared and this will be 4x cubed. And this will go on to infinity. So now we have this x and we need to multiply it by this expression. So we need to somewhat find out the closed form for this expression also. That what's the value of this 1 plus 2x plus 3x squared plus 4x cubed till infinity. So does any of you know what this expression is actually equal to? Then you would like to answer in chat what this expression should be equal to. Same answer is so. Okay, so Akanksha has written the answer to be 1 upon 1 minus x squared. So good job, Akanksha. This would be the correct answer. Like this is actually equal to 1 divided by 1 minus x squared. And one way you can see it is like you can just see that if you put in this expansion of 1 minus x to the power minus n, the value as n equals to 2, you will get that the coefficient of x to the power r's will come out to be something of this kind, which we want. Like if you put, let's say, n equals to 2 here, then coefficient of x to the power r in the expansion of 1 minus x raised to the power minus 2 is nothing but n we have put as 2. So it's just r plus 2 minus 1, which is r plus 1. Choose r. And r plus 1 choose r is just equal to r plus 1. So it says that in the expansion of 1 minus x to the power minus 2, coefficient of x to the power r is given by x to the power r plus 1. And here we see that this indeed is the case, that like x square has a coefficient of 3. Suppose r was 2, then r plus 1 is 3. And so x square has a coefficient of 3. Similarly, x cube has a coefficient of 4, x has a coefficient of 2, and so on. So this is one way to verify it, but maybe I'll just show you guys how do we actually arrive at it. So we know that first of all, so one way is just directly looking at this thing and like trying to fit in the proper formula. But a more intuitive way in which you can see like you can in which you can even see how this formula comes about. Like if you are not clear like how do we arrive at this formula, that coefficient of x to the power r in this is given by n plus r minus 1 choose r. So I'll discuss it with you guys, like how do we arrive at these sorts of formulas. So first of all, we know that like let's just put a space here. So we know that fx is equal to something like this. And now we are discussing how do we calculate an infinite sum like this, because this is not a GP, so we don't know exactly how to do this. So we know that some people like to do this using what they call AGP. So you might know what a AGP is, and you can use it to find out the sum, but I'll discuss something else. So we know that 1 divided by 1 minus x. So let's just start with assuming we know that like this is a very standard equation, that 1 divided by 1 minus x is equals to 1 plus x squared plus like, okay, plus infinity. So 1 divided by 1 minus x is nothing but 1 plus x squared plus x cubed till so on, till infinity. And now if we differentiate both sides with respect to x, so I hope everyone is comfortable with differentiation, because the differentiation is discussed in high school. So differentiating both sides with respect to x, we get, so what do we get here? So if we want to differentiate the function, so if the function, if these two are equal, then their derivatives are also equal, right? So let's just say the derivative on the left hand side is something like derivative. What will the derivative of 1 by 1 minus x? It will be nothing but, I hope everyone remembers the chain rule. This is just 1 minus x raised to the power minus 1. So by chain rule, you can see that its derivative will be something like minus 1 times 1 minus x raised to the power minus 2, and then again multiplied by minus 1, because derivative of 1 minus x will be again minus 1. So this will come out to be a 1 divided by 1 minus x squared. So this will be the derivative of 1 upon 1 minus x. And what will this be equal to on the right hand side? So derivative of 1 we know is 0. Derivative of x is 1. Similarly, derivative of x squared is 2x. X cube is 3x squared plus 4x cube. And this goes on. So from this, actually, you can see that 1 plus 2x plus 3x squared plus 4x cube till infinity is indeed equal to 1 divided by 1 minus x squared. So like even if you don't want to put in the plug in these values here of n and find out which is the correct value, you can just do it using this. And note that to obtain formula of this kind, like expansion of 1 minus x raised to the power minus n, the coefficient of x to the power r, what you can do is just apply derivatives repeatedly. Now again, you can differentiate both of these sides, and you will obtain something like 2 divided by 1 minus x raised to the power cube or something. And that will be equal to, again, derivative of this side. And from that, you can obtain 1 minus x raised to the power minus n's value. Like if you differentiate both sides n times, then you'll obtain this expression also. So yeah, this calculus trick is, I find it very neat and very beautiful. And yeah, from this you can obtain various expansions. So if we just knew this expansion, then we can derive a variety of expansions by just differentiating. Like by differentiating once, we get this expansion. By differentiating like n times, we'll get something like expansion of this kind of term, which is pretty good. So yeah, so plugging in this value, so putting this value in the expression for f of x, we get. So we know that 1 by 1 minus x raised to the power square is 1 plus 2x plus this. So we just plug this value here and we get f of x is equals to x times 1 divided by 1 minus x squared. So yeah, and this is nothing but x divided by, just writing it in a better manner, x divided by 1 minus x. So yeah, and this will be our final answer. So the closed form expression for this generating function of this sequence is equal to this x divided by 1 minus x. Right. I hope it's clear to everyone. Like, if at any point of time anyone has any doubts, then feel free to ask your doubt in chat. I'll try my best to answer it. If you don't ask, I'll just assume that it's clear to everyone. Okay, then. So I guess if we have discussed this fourth question, then we can move on to this fifth one. So because these kinds of generating functions are also useful in counting and this problem is one such problem. We'll discuss some problems in which we'll be using uh, generating functions for counting purposes. So the fifth question asks, in how many ways can 200 players be distributed among 10 teams so that each team gets at least 7 players and not more than 12? And players should be treated as identical objects here. So what this question is asking is, there are 10 teams, there are 200 players, and we need to divide these 200 players into these 10 teams so that each team has at least 7 players and not more than 12 players. So between 7 to 12, every team must have. The number of players in every team must be between 7 and 12, with both 7 and 12 included. And players are treated as identical objects. So we have a bunch of options given also. The coefficient of x to the power 200 in many expressions. So I believe from the options also you guys can get the hint if you have seen the lectures also, like how do we do counting like this. So any idea, guys, what should be the answer here, like from ABCD? Would anyone like to answer in chat? Just answer whatever comes to your mind. Okay. So Akanksha says that the answer is option D. So option D is coefficient of x to the power 200 in x to the power 7 plus x to the power 8 till x to the power 12 whole raised to the power 10. So yes, Akanksha, actually that is the correct answer. So again, good job. So that's for everyone's sake, whoever is watching on YouTube, I'll just be discussing this problem again. So we know that every team, it's given to us that every team will consist of either 7, 8, 9, 10, 11, or 12 players. Right? One of these numbers is the only possible numbers. Between 7 and 12, only these are the integers. And now we know that number of teams is given to us as 10. So there are 10 teams given to us. And now what we need to do is we need to assign all of the each of the 10 teams some players such that each team gets greater than equal to 7 players and greater than equal to 7 and less than equal to 12 players such that the sum of players assigned over all teams is equal to 200. So every team should have between 7 to 12 players, and total number of players assigned over all teams should be 200. Because we need to assign every player to some team. And now, what will this be equal to? So what I claim is this can be thought of as finding the coefficient of x to the power 200 in the expansion of x to the power 7. So maybe maybe while typing, let's just explore why will this be the case. So what is given to us is that the players are identical, right? So what we are interested in is not the ordering of the players, which player goes to what team. We are just interested in the number of players going to each team. Like it does not matter to us that if suppose both team get one player, suppose there are two players and there are two teams, if each of those teams get one player each, then we don't need to come like suppose players are P1 and P2 and teams are T1 and T2. If P1 goes to T1 and P2 goes to T2, and there is another case where P2 goes to T1 and P1 goes to T2. So if players were distinct, then we would have counted these as different cases. But here it's given to us that players should be treated as identical objects. So it does not matter to any team which player goes onto it, either P1 or P2, as long as one player is going. So we will count it as only one case that P1 goes to T1 and P2 goes to T2 and P2 goes to T1 and P1 goes to T2. We don't count it as separate cases. These are just one case where both teams get one player each. So this is the idea here that all players are identical. So we are just interested in the number of players in each team. And now what's the number of players in each team possible? Each team can have 7, 8, 9, 10, 11, or 12 players, right? So x to the power, suppose the variable x to the power 7 corresponds to 7 players. Similarly, x to the power 8 corresponds to 8 players. Similarly, x to the power 9, x to the power 10, x to the power 11, and x to the power 12. So it's given to us that this one team will have one of these numbers at one point of time, right? And now what we want is there are 10 teams given to us. So each of those teams must choose one of these powers. So if one team chooses 10, other might choose 11, another might choose 12, and so on. So there are 10 teams. So each of these 10 teams can choose one of these powers, right? This factor can be 10 times. And now what we want is the total number of players across these 10 teams should be 200. So the sum of powers should come out to be equal to 200. That's why we say coefficient of x to the power 200 in the expansion of this. So I hope this makes a bit of sense. So Sanatan has written in chat that the answer should be A. So Sanatan, in option A, the power raised is equal to 12. But note that we have only 10 teams. So we only divide these players in 10 teams. So we just want 10 types of these polynomials. And that's why we have like raised to power 10 and not raised to power 12. Does this make sense, Sanatan? Okay, it makes sense. Cool. So this will be the answer for us. That coefficient will be equal to this. So hence, option D is correct. Okay, another thing which I want to let you guys know, so maybe you can actually put as a note. So note that in this question, like such simple calculation was only possible because we were given that players should be treated as identical objects. So the above correspondence was possible only because layers were identical objects, and so we were not interested in, and we were just, and so we were just interested in the number of players in each team. But just a remark or just a note that we could have made this coefficients correspondence just because we were considering only the number of players in each team. We did not, like, if the players were distinct, then this sort of way would have been wrong, because then we need to consider if player one goes to one team and player two goes to second team, and the reverse case also. And if suppose players were distinct, so suppose players were not identical but players were distinct, then do you guys think that we would have been able to write, like, not like this polynomial correspondence would not have been correct, but do you guys think we could write some other polynomial correspondence, like some other generating function correspondence? What if the players were not distinct? So just think about it. I want you guys to think about it for like 5-10 minutes. Like, what will happen if this is the case? Can we find something like, can we again form some sort of polynomial and say that in this case also it will be the coefficient of like some variable raised to the power something in an expansion or something? So just think about it. Like, I'll just mute myself for like 5-6 minutes. Like, it's 6:53 till 7. I'll mute myself, and if anything comes to your mind, guys, just type it out in chat and we'll see. Like just think about it. Like, what will happen if the players are not distinct? I'll just be muting myself and think about it for 5 minutes and type in chat whatever comes into your mind. So as a hint, I would suggest you guys to make a correspondence of this with, let's say, in the combinatorics also we studied that what if we want to divide A plus B objects into like A objects are one time and B objects are in the second basket or something like that. And there we get something like A plus B factorial divided by A factorial B factorial. So can we do something similar here also? Okay, so Sanatan is saying that it is not possible if distinct using permutation and combination possible. So I'm saying, Sanatan, that I'm not saying you to explicitly calculate it. Like calculating the finding out coefficient of x about 200 in something like this is also like not directly too easy, but at least making a polynomial correspondence is possible for us. So I'm saying, can you make a polynomial correspondence in this case also? And Akanksha is saying that it can be something like a multinomial theorem. So Akanksha, I believe you are very close to the cracking the correct idea. So maybe I would give 5 minutes more. Like you're on the right path. Like definitely one can think related to multinomial theorem. Like just think about like what will we do if we apply multinomial theorem here? Like what will the polynomial be and like how will multinomial theorem help us here? Like, since you're close to the correct idea, I'll give you 5 minutes more. So I'll be muting myself 5 minutes. So Nathan, you should also like think in terms of multinomial theorem now. I would suggest. Okay, so I see you guys, both of you are almost at the correct solution. So Akanksha is saying that all the people get 7 players, all team get 7 players. But note that Akanksha, that is not a valid case because we want 200 teams, right? So 200 factorial divided by 7 factorial raised to power 10 or something like this won't do for us. But what idea we can get inspired from in multinomial theorem is like what Sanatan has written. Like suppose we are given n objects, we are given n persons, and suppose we are given that first we have to give n1 people to the first team, n2 people to the first team, to the second team, and similarly nk people to the kth team. Then the number of ways to do this is actually equal to, if all the people are distinct, then the number of ways to do this is equals to n factorial by n1 factorial, n2 factorial till nk factorial. This is something which we have discussed using permutation and combinations also. That if there are n objects which are all distinct and we want n1 to be of the first type, like n1 to be in the first team, n2 to be in the second team, n3 to be in the third team, and so on, then the number of ways to do this is just n factorial by n1 factorial, n2 factorial till nk factorial. Right? I hope everyone is clear with this, that why is this formula correct? Like suppose there were 200 people and I knew that I have to put n1 people in the first team, n2 people in the second team, n3 people in the third team, similarly n10 people in the 10th team. Then I could have just written it as 200 factorial divided by n1 factorial, n2 factorial till n10 factorial. But these n1, n2s can also vary. And if these vary, then we'll like sort of use this in the powers. So like I'm just giving you a high level idea first, guys. Now we'll come to the actually like what we'll be doing. So if the players are not distinct, then what happens here? So let us look at a very simple case. Just like let's just look at the in question. Suppose we knew that or maybe yeah, maybe just right. N1 people go to the first team. So there are 10 teams, right? Similarly, N2 people, or maybe not people, but players is a better word since yeah, mentioning players everywhere. N2 players go to the second team, and similarly, like so on, and so on. So we have like 10 numbers N1, N2 till N10. And now we know that since we need to divide all the 200 players, so we know that N1 plus N2 till N10 is nothing but 200, right? Because 10 teams, 200 players. So the number of players over each team is equals to 200. So now we want there are 200 players given to us, out of whom we want N1 to be of the first type of the first team, N2 to be of the second type, which is the second team, N3 to be of the third type, and so on. And all the players are distinct. So now like using multinomial theorem, you can say, or just saying that using permutation combinations idea, we can say that so number of ways to distribute players such that ith team gets ni players is equals to 200 factorial divided by n1 factorial, n2 factorial. And till and 10 factorial. Maybe I should put it here. And so all of it goes in the denominator. So is this much clear to you guys? Because this is bit we have used up a bit of permutation combination here. I can try to explain it a bit more if it is unclear. Right. Okay. So Akanksha says that it's clear. So Sanatan, if you do not write that it's not clear, then I'll be assuming that it is clear to you also. So if we were given these n1 till n10s, then this was the solution. But now note that these n1 till n10 can also vary. And why is that the case? Because we just want like it is possible that in first case the first team gets only second 7 players and the second team gets 8 players. But there is another scenario where the first team gets 8 players and the second team gets 7 players. And these are all distinct scenarios. So total number of ways of distributing players is equals to 200 factorial divided by this. And we'll have like this is when n1 takes a specific value, n2 takes a specific value, and so on. Uh, but now what we want is we want to take the sum of these values. Like we want to take the sum of this over all possible values of n1 till n10. So it will be something like sum of all valid sum over all valid tuples, not just tuples, but n1, n2 till n10. Looking answer for this. Yeah. So sum of these values, sum of this value 200 factorial by this factorial, this over all possible tuples n1 till n10. Same and some are different. Uh, we'll come to that. Like I can discuss that also, but that will be a bit more complicated. Let's just first finish this. So this is not finished. Like I still have not found a polynomial whose coefficient will be something like this. So what I have just said is like total number of ways of distributing players is this. So I know that total ways of distributing players is this, but I want to write it in terms of a polynomial. Let's say I want or a generating function, and I want to like. So now what I can actually do is I can take inspiration from this sort of a generating function. Here I had like here I had x. What did x to the power 7 denote in the first term? It denoted that first team only gets 7 players. Similarly, x to the power 8 denoted first team gets only 8 players, and so on. So x to the power n1 here denotes that the first team gets n1 players. And note that whenever we have n1 players in the first team, we divide by n1 factorial. Similarly, when we have n2 players in the second team, we divide by n2 factorial. So what I can write is, suppose I consider this polynomial now. X raised to the power 7 divided by 7 factorial plus, so the 7 factorial is in the denominator. Maybe I should like uh, write it like this. I should write it in an equation, consider a polynomial. Okay, yeah, I should probably insert an equation. Yeah. So the polynomial for me is uh, x to the power 7, x to the power 7 by 7 factorial plus x to the power 8 by 8 factorial plus x to the power 9 by 9 factorial plus x to the power 10 by 10 factorial plus x to the power 11. Okay, now this is getting a bit redundant, but nonetheless, let's just combine this. X to the power 12 by 12. And let's say I raise all of this to the power 10. So do you guys see here what will we get from this? What will coefficient of x to the power 200 give us here? Like if we have x to the power 200, if we take the coefficient of x to the power 200, then some n1 will come from the first factor, some n2 will come from the second factor, some n3 will come from the third factor, and so on. And we will know, and we know if we are taking x to the power 200 that sum of all n1 till n10 is equal to 200. And we'll also have that if n1 comes from like a first factor, then we'll be dividing it by a factor of n1 factorial already. And similarly, n2 comes from second factor, we'll already be dividing it by n2 factorial. N3 from third factor, we'll divide it by n3 factorial. So from this, so from this, we will get the coefficient of x to the power 200, and it will signify the sum over all of these terms. 1 over, like, that's 1 over n1 factorial to n10 factorial, and it's sum over all possible n1s and n1 till n10 tuples. And then our final answer will be just to multiply it by 200 factorial. So if we just multiply this by 200 factorial, then this will be the answer for us. Like in this polynomial, the coefficient of, so this 200 factorial is a constant, which is like in multiplication of the polynomial. And in this, if we find the coefficient of x to the power 200, like in this whole polynomial, if we find the coefficient of x to the power 200, then that will give us this sum, and which will be the total number of ways of distributing layers. Like, so now do you guys see the beauty of like interchanging polynomials to combinatorics and so on? So we have actually, like, it can be seen that uh, the total number of ways of distributing layers is equal to coefficient of x to the power 200 in above polynomial. Okay, I should give a space here. So the answer for us will be just coefficient of x to the power 200 in this. Okay, this was a bit involved, but very cute. So first, like, do you have any doubts in this? Then maybe I'll come to Sanatan's question of what if some players are same and some are different. So okay, so this is clear. So that's nice, guys. Okay, so now if, like, I personally find it very cool. And now if I was coming to Sanatan's question that if some players are distinct and some players are identical. Okay, now that's an interesting question. So if we have a mixture of identical as well as distinct players, then what do we do? Hmm. I'll have to think about it. I don't know directly what we will do, but let me think about it for 2 minutes. If uh, I'm not able to think, then maybe I we can take it up in the next session. But if you guys also have any ideas, like what will happen if some players are same and some are different, please write in chat. I'll also just think about it. I'll just mute myself, I think. Okay, I don't know, like I'm not able to think of a way if what if some players are distinct and some are same for that. One idea which I have in mind is maybe I'll have to work through it, but that's like it's a really nice question, first of all. So a high level idea which I have in mind is maybe like suppose there were 100 same and 100 distinct people, and obviously like 100 distinct are also distinct from the 100 group of same people. Uh, Maybe I can distribute the distinct people first, or maybe I can distribute the like same people first, and then I can distribute the remaining as distinct people. And this kind of idea might get us somewhere. Like suppose I first distribute the 100 distinct people. So distributing 100 distinct people can be found out by just finding coefficient of x to the power 100 in like again this expression which we discussed. And now we have to like uh, and now we have to distribute some of the same people also. Yeah, like uh, I don't I don't know what can be done here. Yeah, maybe like if I get anything like I'll just maybe we can discuss it in the next session, or I'll just while uploading this document I'll just post for that query also at the end of this document. But for now, maybe we should move on to the other questions. So this was one of the most interesting things which I had to discuss today, and some more questions are there, but I don't think they will be as interesting. So I guess maybe we should move on to the other questions. Otherwise, we'll run out of time. Uh, so the sixth question asks us, how many five-lettered words can be formed from the following words, given that you have to pick one letter per line? So note that it is mentioned that we can only pick one letter per line. So one letter per line means like either we pick this pair of letters RA from here, or this P here, or this T here. Then from the second line, we pick either E, Q, or S. Then from third line, either we pick G or we pick I, O, N. So we need to pick one from each of these three. And now we want to find how many five-lettered words can be formed. So note that from first line, so we need five-lettered words. So we need to ensure that total number of letters is 5. So we can sort of form a polynomial and find out the coefficient of x to the power 5. The high level idea will be to form a polynomial in which we need to find the coefficient of x to the power 5. So you can just see that from first line, there is one, the first number has two characters. So it contributes a factor of x square, like because it contributes a coefficient of 2 in the exponent, because its length is 2. And similarly, this P is one lettered, so it contributes 1 x raised to power 1. Similarly, this T also contributes x raised to power 1. Now from second line, okay, what do we get? We get a factor of either x or x or x. Like all of these have uh, only one length. So x raised to power 1, x raised to power 1, x raised to power 1. And similarly, from third line, we get this is x raised to power 1 and this is x raised to power 2. So note that why are we forming these three polynomials individually for each line? Because at a time we are allowed to only select one letter per line. And this is what we do generally in polynomial multiplication, right? We choose one of these three, multiplied by one of these three, and multiplied by one of these three. And like sum this over all possible choices of choosing. So now what do we want is since we need to form a 5-letter word, we need to find the coefficient of x to the power 5 in the expansion of this thing, x squared plus 2x. So I'll just write x squared plus x as x squared plus 2x because it's the same. So x squared plus 2x, then this is 3x, and then this is x plus x cubed. And to find the coefficient of x to the power 5 here, like you can calculate that the coefficient of x to the power 5 will come out to be so this 3x will come out. So we need to find in the remaining the coefficient of x to the power 4 and multiply it by 3. So 8x plus x cubed times x squared plus 2x. We'll need to find coefficient of x to the power 4, which will be something like x plus 2 times 1 plus x squared. So it will come out to be 6. Like from this, you can see that. Like if you follow this, like I'm doing this orally, but you can also do this yourself, and this will evaluate to 6. So yeah. So the coefficient of x to the power 5 in the expansion of this will come out to be 6. And so the number of such words. Hence, the number of such words is equals to 6. So I hope everyone understands like why did we multiply these polynomials and found out, because from each of these lines we had to pick one word. So x square denotes that we pick the word RA. One of the x's here denote P and other denotes T. Similarly, 3x here denotes one of E, Q, and S. X plus x cubed denotes like either G or I over. But there's another catch here. Maybe you guys have caught on it already, but I'll still discuss it nonetheless. So maybe I should leave a note. So we have calculated the above answer. So one thing, this is something which you guys should also think about whenever we are discussing any counting question, like that. Are we considering distinct? Are we considering same elements? Are we considering any permutations? Or are we considering just combinations and something like this? So here in this answer, actually, you can observe that I did not consider any combination like permutations of the word. Like I said, I'll take one word from here, one letter from first line, one letter from second line, and one letter from third line, and that I counted as one. Like it will be one instance. So if I take RA from the first line, Q from second line, G from third line, then RAQG is the 5-lettered word, and I won't count anything else. But note that there can be other possible words also, right? If I like using RA, Q, and G, I can put Q at the first, RA second, and G at the third. So if I am allowed to reorder these words amongst each other, like for now, I'm assuming that the word will always be formed by first putting a letter from the first line, then putting the letter from the second line, then putting a letter from the third line. So we have calculated the above answer, assume that we are not doing any permutation of the words from different lines. So we are always assuming that line one's word will come before line two's word, and it will come before line three's word. But if we were allowed to permute, if we were allowed to permute each of the selected triplets, so at a time we are selecting 3 words, right? Each of the at a time we are selecting 3 words, right? One from the first line, one from second, one from the third. And if we are allowed to commute okay, maybe I should just type like this. Then each of the selected triplet can be commuted. So how many ways, like in dash ways? So I'm giving a line here, like what do you guys think that what should come here? If we were even allowed, so we were given these triplets, RA, Q, and G, suppose, and if we are allowed to like permute these, then how many ways can I permute these amongst each other? Right now, this answer 6 just assumes that I'm not permuting them. I'm taking the RA first, then this Q second, then this G third. But if I'm allowed to permute also, then in how many ways can I permute one such combination? Like RA, Q, and G, in how many ways can I permute it? Any guesses? Akansha? Now, this is a straightforward problem. I believe you should be able to answer this. Like given these triplets, given any at any point of time, given the triplet of words, in how many ways can you permute those triplets? Yeah. This is nothing. It will be 3 factorial ways, which is just 6. There are times of ways in which each triplet can be computed, and each triplet can be computed in 6 ways, as we have mentioned. Is my screen visible, guys? Like I just saw something like a network connection. Okay, I'll just reshare. Because it shows that I have a network connection issue. Okay, like I think I have shared it. Yes. So is it visible now, Sanatan? Sanatan Akanksha? I believe it should be visible now. Okay, nice. So now, if we are allowed to permute, then each of the selected triplets will be permuted in 6 ways. And in that case, the total number of possible words formed will be just equal to number of possible triplets times the number of ways in which we can permute each triplet, which is just 6. So this comes out to be number of possible triplets times 6, and number of triplets is just 6. So 6 times 6 is the answer, which is 36. I'll just underline this also, or maybe not. If we had to take the first letter from the first line, second from second line, and third from third line, then the number of ways is 6. But if we were allowed to permute across lines also, then the number of ways will be 36. This is again a good distinction of keeping in mind, like it creates an intuition of when to do permutation and when to not do and stuff like that. So yeah, again, like very good thing. Okay, then so now maybe we can move on to the 7th question. So 7th question says that a bag contains several blue, green, purple, and yellow candies. So 4 types of candies are there: blue, green, purple, and yellow, and there are several of them. So several, which just means a lot of them, so we can consider it as infinity. And now the problem asks, in how many ways can Amit eat 6 candies from these blue, green, purple, and yellow colored candies? So how many ways can Amit eat 6 candies from these blue, green, purple, and yellow colored candies? So again, I believe this is a not too hard of a question. So like obviously all candies are like if a candy is blue colored, then all blue colored candies are same for us. We don't count like eating the first blue colored candy and second blue colored candies as different. Like this is obvious for us. So we are just interested in the count of each of the candies. Like how much blue candies are we eating, how much green candies are we eating, how much purple and how much yellow are we eating. So this is not too difficult. So like, so let us consider this again. This function 1 plus x square plus x cubed till infinity. So this denotes, let's say, this function denotes the number of blue candies that I eat. Similarly, this will also denote the number of green candies I eat, purple as well as yellow. And so sort of I raised it to the power 4 because each of these factors denotes like one thing. Like the first factor will denote the number of candies, blue candies eaten. The second will denote number of green candies. Third will denote purple, and fourth will denote yellow. And each of these parts. So if we select x square from first, it will denote that I have eaten two blue candies. Similarly, x cube in the second factor will denote taking 3 green candies and so on. So if we take this function, then we just need to find the coefficient of x to the power. So what power would we need to find the coefficient of here? Like, so need to find the coefficient of x raised to the power. And guys, this is a straightforward answer. Like, we need to find the coefficient of x raised to the power what in this expansion. Okay, so maybe I guess I should answer it myself. Okay, so Nathan is typing something in the chat. Yes, good job, Sanatan. It's x raised to the power 6. Just making sure that you guys are paying attention. So yeah, this is a straightforward thing. So we just need to find the coefficient of x raised to the power 6 in the expansion of this. And this is nothing but just, so this part is 1 divided by 1 minus x. We already know. And so this just comes out to be 1 upon 1 minus x raised to the power 4, which is just 1 minus x minus 4. Now the coefficient of x raised to the power 6 in expansion of 1 minus x raised to the power minus 4 is, we already know, like, hence the answer or the number of ways is equals to, so we already know like coefficient of x raised to the power r in expansion of 1 minus x raised to the power minus n is nothing but n plus r minus 1 cr. And n here is 4. So 4. R here is 6. So 6 minus 1. Choose R. And R again here is 6. So 4 plus 6 minus 1. Choose 6. It's the answer for us. And this will be nothing but 4 plus 6 is 10. 10 minus 1 is 9. Right. So 9 choose 6, which is just equal to 9 times 7 times 987 divided by 6. So 9 into 8 by 6 is 3 into 4, 3 into 4 into 7. So 7 in 3 to 4 is 12. So 12 times 7 is 60, 72, 84. So this will come up to 84. Yeah. So this will be the correct answer. You can check it later also. So yeah. So number of ways is 84. And this is the answer for us. Okay, you have already written 84 in the chat. So good job, Sanathan. Okay. Now I think eighth question is pretty difficult. Again, just find the closed form of the expression of generating function. So maybe we can just see this directly. So this is the sequence given to us 111, 121, 133, 114641. So just observe that this sequence is just multiples of 11. So the generating function is just 1 plus 11x plus 121x squared plus 1331x cubed and so on. So which is nothing but 1 plus 11x plus 11x whole squared, yeah, plus 11x cubed. So, and this is just, it's easy to see that it's just 1 divided by 1 minus 11x, because just 1 plus y square plus y cube till infinity. If you put 11x as y, and that will be 1 by 1 minus y, and I just put y equal to 11, 1 minus 11x. So I hope this is pretty straightforward. So I don't have to discuss this further. But if there are any doubts, Sanatan, do feel free to ask in chat. I'll try to explain it. Sure. Okay, again, ninth is also a straightforward question, just based on binomial theorem. So state whether true or false. So state whether it is true or false, and the problem is like 1 plus x raised to the power 6 is the generating function for this sequence. So the sequence is 620, 621, 622, which is 626, and is 1 plus x raised to the power 6 the generating function for this. So what do you think, Sanatan? Is it a generating function for the sequence? Okay, so why do you feel, okay, Sanatan is saying no. So why do you think this is not a generating function? So for the generating functions are defined as, so the constant term should be 620. So like if I write this in the form of a naught plus a1x plus a2x squared plus a3x cube and so on, then it should correspond to this sequence. And I believe this will correspond to this sequence. Like applying binomial theorem, you will get like x raised to the power 6 plus x raised to the power 5's coefficient will be 6 choose 5. X raised to the power 4's coefficient will be 6 choose 4. Similarly, 6 choose 3, 6 choose 2, 6 choose 1. Yeah, so summation akxk. So there are, so you can write as summation akxk, but like we discussed, like the closed form expression of the generating function is also generating function itself. So it's the generating function itself. The akxk form is just the expanded form, and this is just the closed form. So this is just the closed form, that is the expanded form, but these are indeed the generating functions. Both of these will be same. Like if you write it in some like 620 plus 621x plus 622x squared or so on, that will be just same as this, right? This is also a generating function. This is just the closed form of the generating function. I hope that is clear. So this is just true. Yeah. And likewise is true, just adding one line as 1 plus x raised to the power 6 as a coefficient of x raised to the power r of 6 choose r for x raised to the power r for r from 0 to 6 and 0 otherwise, or 0 for, so something like this. So x to the power 6 as a coefficient 6 choose r for x to the power r for our function to 6. So these are all correct, and 0 for higher powers, which is also. Okay. So now we move on to the next question. So this is also not too difficult of a question. So it asks, what is the sequence generated by the function? So this is the function given to us, 1 plus x divided by 1 minus x cubed. And we need to find the sequence generated by the function. So these types of questions can sometimes seem like they are very difficult or very complicated, but it's quite simple. Uh, just do it like this. So we just try to break this down into a simple expression. Like suppose we are given this. Suppose this is the function given to us f of x. Then we can just break f of x into two parts, right? This 1 plus x can be just written as like 1 divided by 1 minus x cubed plus x divided by x minus x cubed. So I'll just copy this and yeah. So this is nothing but 1 divided by 1 minus x cubed plus x divided by x 1 minus x cubed, right? So this is the sequence for us. And now what will this be equal to? So this will be nothing but I should just insert an equation. And so this 1 divided by 1 minus x cube will be nothing but we already know like how to expand this. So this will be 1 plus 3x plus. So we already know like how to expand 1 minus x raised to the power minus n, right? The coefficient of x to the power r there is n plus r minus 1, choose r. So this will come out to be something like 1 plus 3x plus 6x squared plus I don't know, it will be like I believe 6 plus 3 will be 9. 4, 9, 7. It should be 7 or what? When we put r equals to 3, it will be 3 plus 3 minus 1. 6, 1, 5, choose 3, which will be something like 10. So this will be 10x cubed. And like so on. So this first, I'm just expanding the first part. Like this part will correspond to this. And the second part is just x times this. So plus x times this thing. Right? Yeah. And now like you can easily see that it can be seen that so this will be just equal to having a bit of trouble with copying and pasting. Yeah. So just see that the coefficient of 1 will remain 1 because 1 we get from here and we don't get any 1 from here. So 1 will remain 1 only. And now what will be the coefficient of x? So 3x comes from here. And from here we get x times 1. So we'll get it as 1 plus 4x now. So like maybe I should just write it step by step here. We get 1 because 1 is the only thing here. Then we'll get 4x because I get 3x from here and I get like only x from here. And then what I'll get is for the coefficient of x squared, what will I get is I'll get a 6 from here. But on this side, only I'll get a 3 because it will be 3x squared. So I'll get a 9x squared. Similarly, I'll get a 10x cube here and I'll get a 6x cube here. So it will be plus 10x cube. And like this will continue. So on. So you can see that there is this pattern which we have already seen, that it is 1 plus 4x plus 9x squared plus 16x cubed and so on. So the coefficients are just perfect squares. So the sequence obtained is just the sequence of perfect squares. So the sequence is equal to 1, 4, 9, 16, and similarly it will go on to 25 and so on. Dot, dot, dot. So the function corresponds to the sequence of perfect squares. Yeah. Something like this. Okay, so Sanatan is okay. First of all, so this was all I had for the day. The last question for the day, which I had. So yeah, now I can take up out. So Sanatan is asking that, can you tell further about closed form? So Sanatan, there is nothing technical about closed form. It's just uh, so by closed form, what we mean is, suppose we don't want to write the whole summation a k x raised to the power k. Because like suppose I have to write 1 plus x square plus x cube plus x raised to the power 4 till infinity. And suppose I have a more compact formula for this. So closed form is nothing but a formula. It's just an equation like a there's this there is this sum. So let's say suppose uh, there is a sum 5 plus 2 plus 2 plus 2. Suppose there is this sum which is 5 plus 2 plus 2 plus 2. So you can write it in that form, that you can take a lot of time and write 5 plus 2 plus 2 plus 2 all the time. Or you can just write 11. So similarly, this is what closed form is also like. We don't want to write everything. It's just you want to write it in a shorter manner. So obviously, like it is always not possible to write, like it is not necessary that every sequence will have a closed form. But yeah, like you can think of closed form as just an identity. Suppose like if you write a square plus b square plus 2ab, then I can say that it's closed form. Like by closed form, I just mean a more compact form. So instead of writing a square plus b square plus 2ab, I can write it as a plus b whole squared. So that way I'll say that a plus b whole squared is the closed form of a square plus b square plus 2ab. So in similar manner, I'm saying that for something like this expression, like uh, let's say this expression 7 plus 0x, this 7 plus 7x squared plus 7x to the power 4 plus 7x to the power 6 is infinity. Its closed form, I'll just write it as 7 by 1 minus x squared. That instead of writing these so many terms, I'll just have to write this one term. And this is what I mean by closed form. Like even the a plus b whole squared is a closed form for a square plus b square plus 2ab. So there's nothing fancy or technical about it. It's just formula. Okay. I hope it's clear. So cool. So I guess this was all the questions and the topics I had to discuss for today. So these are 10 questions. So if you have any, like we have 5 minutes remaining. So Nathan, if you have any doubts or any comments, then feel free to ask in chat. Otherwise, uh, we can close the session also if there are no doubts or any comments. Okay, so Nathan is typing something in the chat. Okay, sure, Sanatan. So I'll be sharing this like usually I share it in the Google Drive, which everyone already has the link of. And yeah, I'll also upload the session on the YouTube channel today. Like by tonight, I'll try to do it. So yeah. So once again, I guess since there are no further questions, so once again, just thanks for attending the session. Hopefully, see you guys again next week, same timing, 6 to 8 p.m. So till then, goodbye. You can leave the session. I'll just stop the recording and close it.